Hello, in this video we will study the relationship between stress and strain in two dimension and three dimension system. In previous video we have studied the relationship for stress system in one dimensional. Okay, I hope you have remember the relationship between them. That is very easy. Normal stress upon corresponding strain equals to your Young's modulus. Okay, that is only the relationship between stress and strain in your one dimensional system. Okay, now for two dimensional system, in this video, we will study for two-dimensional stress system, three-dimensional stress system, and some numericals of bars on tapering section, varying section. Okay. Now, for two-dimensional stress system, before studying the two-dimensional stress system, we have to study some basic type of stress and strains. Okay, that is longitudinal strain, lateral strain, and Poisson's ratio. Okay, these three things are very much important in this whole concept. Okay, first is longitudinal strain. uh, this is also very simple. When a body is subjected to an axial tensile load, there is an increase in length of the body. Okay, but at the same time there is an decrease in another dimension of the body at right angles to the line of action of applied load. तो यहाँ पे क्या होता है कि जब किसी भी बॉडी पे और किसी भी स्ट्रक्चरल मेंबर पे जब एक्सियल टेंसाइल लोड एक्ट होता है तो क्या होगा, टेंसाइल लोड दैट मीन्स द पुल लोड. Okay, that load is pulling the material in outward direction. Okay, when the material is pulling in outward direction, what happened, at the same time the length of that material or length of that member will increase, but at the same time the width or breadth of that material will be decreasing. Okay, at the right angle, when whichever the dimension is at the right angle, that dimension will decrease, and at the x axis or at the y axis, exactly perpendicular to that axial dimension, that dimension will increase. ओके, तो यहाँ पे क्या होता है, जब कोई भी टेंसाइल लोड किसी भी मेंबर पे एक्ट होगा तो क्या होगा, जिस डायरेक्शन में वो टेंसाइल लोड एक्ट हो रहा है उस डायरेक्शन में उसकी डायमेंशन इंक्रीज होगी. ओके, और उसके अपोजिट क्या होगा कि जो पुल फोर्स एक्ट हो रहा है उसके एक्सियल डायरेक्शन में, दैट मीन्स परपेंडिकुलर डायरेक्शन में, जो भी उसकी डायमेंशन है वो डायमेंशन क्या होगी, डिक्रीज होगी. ठीक है, नाउ हियर वी आर कंसिडरिंग दैट द एक्सियल लोड इज अप्लाइड in the direction where the member is having its length. Okay, so the length of that member is increasing, and at the same time the at axial direction the breadth or width of that member is decreasing. Okay, now the body here having the axial deformation. Okay, what the having that body is having a axial deformation. Okay, and at the deformation at the right angle also. ओके, राइट एंगल पे भी क्या होगा, डिफॉर्मेशन होगा, बट एट द सेम टाइम एक्सिस जो है, लाइन ऑफ एक्शन का जो एक्सिस है, उस एक्सिस पे भी क्या होगा, आपका डिफॉर्मेशन होगा. दैट डिफॉर्मेशन इज कॉल्ड एज अ एक्सियल डिफॉर्मेशन. ओके, नाउ axial deformation is also called as your lateral deformation. ओके, lateral deformation भी lateral deformation मतलब क्या है, जो लाइन ऑफ एक्शन है, लाइन ऑफ एक्शन के अलोंग जो आपका डिफॉर्मेशन होगा, दैट डिफॉर्मेशन इज कॉल्ड एज योर एक्सियल डिफॉर्मेशन. एंड ऑल्सो एट द सेम टाइम जो परपेंडिकुलर डायरेक्शन में डिफॉर्मेशन होगा, दैट डिफॉर्मेशन इज ऑल्सो कॉल्ड एज योर lateral deformation. Okay, now next thing is how to write this longitudinal strain. How to write this longitudinal strain. Longitudinal strain can be written as dl upon L. Strain is nothing but, you have already studied, strain is nothing but your change in dimension upon original dimension. Okay, but here the thing is that longitudinal strain में only आपका length change होगी, और उसका जो ratio है change in length divided by your original length is nothing but longitudinal strain. Okay, longitudinal strain, here L is nothing but your length of body, P is nothing but tensile force acting on the body, and delta L is nothing but the increase in length of body in the direction of P. Okay, so this thing is your longitudinal strain, delta L upon L. Now the lateral strain. Lateral strain is nothing but longitudinal strain के right angle direction में जो भी strain हो रहा है, that strain is nothing but your longitudinal strain. Lateral strain. The strain at right angles to the direction of applied load is known as your lateral strain. So suppose I'll show you some diagram here. Look at this diagram. There is a rectangular block at the having the dimension d and b. Okay, now here the breadth is b and depth is d. Okay, and the overall length of this rectangle is L. Now this is subjected to an axial tensile load P. This is your axial tensile load P. Now the length of bar will increase while the breadth and depth will decrease. Here the length is increasing. You can see here that the length is here increasing while the depth and the breadth is decreasing by some value. Here in this diagram, the dotted portion shows that the breadth and depth is decreasing by delta B and delta D. Okay, delta B and delta D, and here the length is increasing by delta L. So the depth will be D minus delta D and breadth will be B minus delta B. Here the value should be delta D. Okay, now the longitudinal strain, what will be the longitudinal strain in this डायग्राम, एज आई हैव ऑलरेडी एक्सप्लेन, लॉन्जिट्यूडनल स्ट्रेन विल बी, जिस डायरेक्शन में आपका फोर्स है, उस डायरेक्शन में जो डायमेंशन चेंज हो रही है उसका रेशो विद द ओरिजिनल लेंथ और ओरिजिनल डायमेंशन, दैट इज नथिंग बट योर लॉन्जिट्यूडनल स्ट्रेन. एंड उसकी अपोजिट डायरेक्शन में जो भी डायमेंशन चेंज हो रही है वो उसका रेशो विद द ओरिजिनल डायमेंशन इज नथिंग बट योर lateral strain. Okay, in this case longitudinal strain will be corresponding to the length. Okay, and lateral strain corresponding to the breadth and depth B and D. So longitudinal strain here will be longitudinal strain equals to delta L upon L. Okay, delta L upon L, because the value is changing by delta L. And lateral strain here will be delta B by B and delta D by D. Delta B by B and delta D by D. Okay, because फोर्स के एक्सियल डायरेक्शन में ब्रेड्थ एंड डेप्थ चेंज हो रही है, और फोर्स के डायरेक्शन में क्या चेंज हो रहा है, आपका लेंथ चेंज हो रहा है. Okay, I hope you understand the lateral strain and lateral longitudinal strain. Okay, longitudinal strain and lateral strains. longitudinal strain जो होगी वो फोर्स के डायरेक्शन में होगी, और उसके एक्सियल डायरेक्शन में और परपेंडिकुलर डायरेक्शन में जो भी स्ट्रेन प्रोड्यूस होगा वो स्ट्रेन आपका क्या होगा, लैटरल स्ट्रेन होगा. नाउ हियर नॉट नेसेसरी कि लैटरल स्ट्रेन आपका एक्स डायरेक्शन में ही होना चाहिए. That can be in the y direction also, because if the force is applied in from the y direction or from the z direction, then what happened, the longitudinal strain will be from the y direction and from the z direction. Okay, and at exactly opposite, when the force is applied from the y direction, the lateral strain will produce from x direction. Okay, so and also if the longitudinal strain is tensile, then what happened, the lateral strain will be compressive in nature. From the diagram we can easily understand that here what happened, the length is increasing, that means the tensile strain is there. Okay, but at the same time what happened, this dimension is decreasing, that means the breadth and depth is compressed by some value, that means delta d and delta b. So the lateral strain is in compressive nature here, and the longitudinal strain is in tensile nature. Okay, but if this force P is acting in opposite direction, that means in compressive nature, अगर ये P जो है वो टेंसाइल ना होके कंप्रेसिव फोर्स के जैसे एक्ट हुआ तो क्या होगा, द लेंथ विल डिक्रीज. Okay, because that if compressive force is acting in axial direction, then what happened, that force is pushing the material or pushing the member in inward direction. ओके, अगर कंप्रेसिव फोर्स हुआ तो लेंथ क्या होगी, पुश होने की वजह से डिक्रीज होगी, एंड एट द सेम टाइम एक्सियल जो आपकी डायरेक्शन है उसमें क्या होगा, ब्रेड्थ आपकी इंक्रीज होगी. ओके, डिफॉर्मेशन कहाँ पे होगा, लेंथ पे होगा, लेकिन लेंथ पे कंप्रेसिव नेचर होगा, और जो ब्रेड्थ है, ब्रेड्थ की साइज जो है वो इंक्रीज हो जाएगी. ओके, सो ब्रेड्थ क्या होगी आपकी, टेंसाइल नेचर में होगी. So if longitudinal strain is compressive, then lateral strain will be tensile. Okay, and the vice versa, that means ये exactly opposite है, lateral strain compressive हुई तो सॉरी longitudinal strain compressive हुई तो lateral strain क्या होगी, tensile होगी, और अगर longitudinal strain tensile हुई तो lateral strain क्या होगी, compressive होगी. Okay, remember this both are should be opposite in nature, and the vice versa. Okay, now every longitudinal strain in the direction of load is accompanied by lateral strain in opposite kind of, in all direction perpendicular to the load. The lateral strain is exactly in perpendicular direction to that of longitudinal strain. Remember this. Now second part is your Poisson's ratio. Okay, Poisson's ratio is denoted by mu. This symbol is nothing but mu. Okay, mu. Now the Poisson's ratio. The ratio of lateral strain to the longitudinal strain is a constant. Okay, for given material. When the material is stressed within the elastic limit, this ratio is called as Poisson's ratio and is generally denoted by mu. Okay, what is mean by Poisson's ratio? That ratio of lateral strain to longitudinal strain. Okay, remember lateral strain divided by longitudinal strain is nothing but Poisson's ratio or mu. Okay, but the what is the condition, condition is that material should be stressed within elastic limit. Okay, material is stressed within elastic limit, that means the material should obey the Hooke's law. Material should obey the Hooke's law. So the Poisson's ratio will be your lateral strain divided by longitudinal strain. Okay, now from this formula we can find out the lateral strain. Okay, lateral strain will be mu into longitudinal strain. Okay, mu into longitudinal strain, but here the value of lateral strain is in exactly opposite direction. Okay, so I have written the sign negative here. ओके, वाई, बिकॉज क्या होता है कि लैटरल स्ट्रेन जो है, एज आई हैव ऑलरेडी एक्सप्लेन, लैटरल स्ट्रेन जो है वो क्या होगी, एग्जैक्टली इन परपेंडिकुलर डायरेक्शन होगी ऑफ दैट ऑफ लॉन्जिट्यूडनल स्ट्रेन. ओके, सो अगर टेंसाइल हुई तो लैटरल स्ट्रेन क्या होगा, कंप्रेसिव होगा, दैट मीन्स द टेंसाइल विल बी इन पॉजिटिव डायरेक्शन, दैट मीन्स पॉजिटिव साइन टेंसाइल, एंड कंप्रेसिव विल बी negative. So I have written it written here as lateral strain equals to negative of mu into longitudinal strain. Remember this, lateral strain is in exactly opposite sign or and exactly opposite direction to that of longitudinal strain. Okay, so lateral strain equals to minus mu into longitudinal strain. Now this diagram I have already explained. Now the relationship between two dimensional stress and strain. Now consider this block ABCD. ABCD. Now in x direction the normal stress sigma 1 is acting, and in y direction the normal stress sigma 2 is acting uh, at the both ends. Okay, and this is in tensile nature. Okay, so from this we have to find out the value of lateral strains, longitudinal strains also. Now the stress sigma 1 will produce strain in the direction of x and also in the direction of y. Okay, now if we are considering only sigma 1, then sigma 1 क्या करेगा कि sigma 1 x direction में भी strain produce करेगा and at the same time y direction में भी strain produce करेगा. ये जो डायग्राम है वो अभी जो रेक्टेंगुलर ब्लॉक हमने लिया था इसके सेम ही ये डायग्राम है. क्या होगा अगर ये टेंसाइल फोर्स एट दी बोथ एंड एक्ट हो रहा है तो इसकी बी सी जो साइड है वो बी सी साइड सम वैल्यू से इंक्रीज होगी. ओके, एंड द साइड ए बी विल डिक्रीज बाय सम वैल्यू. ओके, नाउ द स्ट्रेन इन एक्स डायरेक्शन विल बी longitudinal strain, and at the same time the strain in y direction will be your lateral strain. Why? Because this sigma 1 is acting in the direction of x. Okay, so x डायरेक्शन में जो भी स्ट्रेन होगा वो लॉन्जिट्यूडनल होगा एंड y डायरेक्शन में जो भी स्ट्रेन होगा वो लैटरल स्ट्रेन होगा. now this is very simple. The strain in the direction of x can be written as sigma 1 by e. Okay, sigma 1 by e. This is the formula of strain only. That means your Young's modulus equals to stress upon strain. So simply I have shifted the strain to left hand side and strain equals to your stress upon Young's modulus. Okay, whereas the strain in y direction, what will be the strain in y direction? The formula for Poisson's ratio we can use here. The y direction lateral strain can be written as minus mu into longitudinal strain. Okay, minus mu into longitudinal strain. Here longitudinal strain I have written as sigma 1 upon e. Okay, here lateral strain equals to minus mu into longitudinal strain, and longitudinal strain is sigma 1 upon e. And now this is for we have written for sigma 1. Okay, now what happened for sigma 2? Sigma 2 is acting in y direction. Okay, so in y direction longitudinal strain will produce, and in x direction lateral strain will produce. Okay, now again this is also very simple. For sigma 2, y direction longitudinal strain will be sigma 2 upon e, and the x direction lateral strain will be minus mu into sigma 2 upon e. Okay, exactly same as these both strains, but simply we have to write this sigma 2 instead of sigma 1, and the direction we have to remember. Okay, here the longitudinal strain in y direction is sigma 2 upon e, and lateral strain in x direction is minus mu into sigma 2 upon e. Okay, now we have to find out the total strain. Okay, we have to find out the total strain. Total strain is nothing but your e. E is your strain and sigma is your stress. So in x direction we can consider E1 as a total strain, and in y direction we can consider E2 as a total strain. Now simply sum up the x direction strains and y direction strains. Okay, for E1 in x direction, sigma 1 is producing longitudinal and sigma 2 is producing lateral, and in y direction sigma 2 is producing longitudinal and sigma 1 is producing lateral. So simply I am going to sum up these quantities. So E1 equals to sigma 1 upon E minus mu sigma 2 upon E. This is the formula for total strain in x direction, and total strain in y direction will be sigma 2 upon E minus mu into sigma 1 upon E. This equation gives the relationship for two-dimensional stress system. This is for the force applied in tensile direction, but if the force are applied in the compressive direction, then we can easily find out the strains produced by that compressive force. Okay, I hope you understand the basic concepts of the longitudinal strain and lateral strains. Okay, now we'll move further for the three-dimensional stress system. This is also very simple. If you understand the stress system for two-dimensional, then you can easily understand the stress system for three-dimensional. Okay, here a body is subjected to three orthogonal normal stresses. Okay, three orthogonal normal stresses. This face is a z direction, this is your x direction, and this is your y direction. Okay, I'll highlight this. Now in x direction sigma 1 normal stress is acting, in y direction the normal stress sigma 2 is acting, and at the z direction the normal stress sigma 3 is acting. Okay, these all are in tensile nature. Now what happened due to the sigma 1, if sigma 1 if we are considering only sigma 1, then due to this sigma 1 stress, the x direction will produce your longitudinal strain. Okay, because the sigma 1 is in x direction. Okay, so x direction producing sigma 1 longitudinal strain, and in y direction and in z direction the strain producing is lateral one. Okay, and similarly due to the sigma 2, y direction will produce your longitudinal strain, and x and z direction will produce the lateral strains. Okay, similarly for sigma 3, sigma 3, z direction will produce your longitudinal strain, and x and y direction will produce the lateral strains. Okay, I hope you understand. Now consider the sigma 1, only sigma 1. We can write the equation for sigma 1 in x direction. The strain will be sigma 1 upon E, as this is a longitudinal strain, whereas in y and z direction it is equals to lateral strain. So minus mu into sigma 1 upon E will be the strain in y and z direction. Okay, now similarly we can write it for the sigma 2 and sigma 3. Now first strain producing by sigma 2 in y direction will be sigma 2 upon E, and for x and z direction it will be minus mu upon sigma 2 upon E. Okay, now similarly for sigma 3 in z direction it will be sigma 3 upon E, and in x and y direction it will be minus mu upon sigma 3 upon E. Okay, now the total strains, as we have calculated in two-dimensional system, what we have done in that, we simply calculated all these strains, and simply we sum up in x direction and in y direction. Here also we have to do the same, but here one direction is increasing. As this is a three-dimensional system, x, y and z directions are there. For two-dimensional, only x and y directions are there. So here we have to sum up total strain for x direction also, for y direction also, and for z direction also. Okay, so assume that E1 is for x, E2 is for y and E3 is for z. Okay, so total strain in x direction will be E1 equals to sigma 1 upon E. As sigma 1 is in x direction, it is producing longitudinal, and remaining both are in lateral. So E1 is sigma 1 upon E minus mu sigma 2 upon E minus mu sigma 3 upon E. E2 is sigma 2 upon E minus mu upon sigma 3 upon E minus mu into sigma 1 upon E. E3 is sigma 3 upon E minus mu sigma 1 upon E minus mu sigma 2 upon E. यहाँ पे आप ऐसे भी याद रख सकते हैं कि जो इवन स्ट्रेस है, इवन स्ट्रेन है, वो एक्स डायरेक्शन में है, E2 जो है वो वाई डायरेक्शन में है और E3 जो है वो जेड डायरेक्शन में है. सिंपली E1 अगर आया तो हम लोग को क्या याद रखना है कि सिग्मा 1 की वजह से जो स्ट्रेन आएगा वो लॉन्जिट्यूडनल होगा. E2 अगर आया तो क्या होगा कि सिग्मा 2 की वजह से जो स्ट्रेन होगा वो लॉन्जिट्यूडनल होगा, एंड E3 अगर आया तो सिग्मा 3 लॉन्जिट्यूडनल होगा. ओके, simply remember these three quantities. Remaining two quantities are lateral quantities, so we have to simply write it is a minus mu sigma upon E. ओके, ई के बाद जो सफिक्स आ रहा है 1 2 3, उसके हिसाब से भी आपने याद रखा तो भी कोई प्रॉब्लम नहीं है. नाउ मूव टुवर्ड्स द न्यूमेरिकल्स. Okay, I hope you understand the two-dimensional, one-dimensional and three-dimensional stress system and the concepts of lateral strain, longitudinal strain and the Poisson's ratio. This is very simple, but simply you have to remember it very well. Now the numericals on bars of bearing section, the part is very important. So first numerical, some numericals I have completed in second video. A load of 10 kilonewton is supported by a rope taken round a pulley as shown in figure. Determine the stress in that rope and the deflection of load. Okay, this is the diagram. Here this is a pulley from which a rope is carrying. The pulley is carrying a rope. Here it is fixed, and at the one end it is having a load of 10 kilonewtons. At the same both the figures I have drawn here, and this value shows the length of that rope. Okay, now if the load is supported from the pulley, which in turn is supported by a rope as shown in figure, find the stress in the rope and the deflection of the load. The rope section has an area of 1000 mm square, and the modulus of elasticity of rope material is 1000 newtons per mm square. Now here we have to neglect the friction at the pulley. The first condition what we have to do, from figure A we have to determine the stress and the deflection of load, and from figure B again we have to find out the stress and deflection of the load. Okay, now ये जो फिगर है यहाँ पे आप देख सकते हैं, ये पुली है यहाँ पे, और पुली के ऊपर से आप एक रोप जा रही है जिसकी लेंथ यहाँ 6000 mm है, 600 mm है, एंड यहाँ पे 900 mm है. तो टोटल लेंथ कितनी हुई यहाँ पे 1500 mm की लेंथ हुई है ओवरऑल रोप की, एंड एट द वन एंड देयर इज 10 kilonewton load is there. Okay, this is for figure A, and for figure B again 10 kilonewton load is there, but the load is carrying by pulley, okay, which is in turn carrying by rope, okay, because rope की वजह से ये पुली यहाँ पे है, और ये क्योंकि ये पुली फिक्स नहीं है, यहाँ पे ये फिक्स्ड है, यहाँ पे फिक्स नहीं है, और यहाँ पे क्या हुआ है 10 किलो न्यूटन्स का लोड अप्लाई किया है, तो ये भी ये जो लोड है ये पुली और रोप दोनों ही कैरी कर रहे हैं, ओके, और रोप का डायमेंशन क्या है 600 mm एंड 900 mm. Now for we'll consider first for figure A. Now the tension in that rope will be 10 kilonewtons, okay, because the rope is this load is pulling that rope in downward direction, okay, so ये क्या होगा टेंशन फोर्स होगा, क्योंकि ये जो फोर्स है ये फोर्स उस रोप को पुल कर रहा है, ओके, 10 किलो न्यूटन का आपको टेंशन फोर्स मिल गया, तो स्ट्रेस कैसे फाइंड आउट करेंगे, इजी है, load upon your area of cross section, okay, now area of cross section of that rope is given as 1000 mm square, so convert this 10 kilonewtons into newton, 10 into 10 raised to 3 divided by your area 1000, so we'll get this stress equals to 10 newtons per mm square, okay, now the total length of this rope, the example is very simple, the total length of this rope will be summation of 600 and 900, the total length will be 1500, so we can find out easily the extension, that means your delta L, okay, extension of rope will be delta L equals to sigma upon E into L. Young's modulus they have given as 1000, sigma we have calculated as 10, and total length is 1500, okay, this is the formula for your Young's modulus, E equals to sigma upon E, and E again equals to sigma upon delta L into L, so we can get the formula delta L equal to sigma upon E into L. This one I have explained repeatedly in previous video also and this video also. So extension equals to 15 mm, we have get extension of 15 mm here. यहाँ पे एक्सटेंशन जो है वही क्या होगा आपका लोड का डिफ्लेक्शन होगा, ओके, लोड जो है वो कितनी वैल्यू से डिफ्लेक्ट होगा, तो जो एक्सटेंशन रोप में आएगा उतना ही वो क्या होगा डिफ्लेक्ट होगा, क्योंकि जो लोड है वो रोप क्या कर रहा है होल्ड कर रहा है, ओके, तो रोप अगर इंक्रीज हुआ सम लेंथ से, अगर रोप इंक्रीज हुई तो क्या होगा जो लोड है वो भी क्या होगा सम वैल्यू से डिफ्लेक्ट होगा नीचे, ओके, अगर लोड आपका सम वैल्यू से रोप जो है जो सम वैल्यू से डिक्रीज हुई तो क्या होगा जो फोर्स है और जो लोड उसके उस पर एक्ट हो रहा है वो भी क्या होगा उसी वैल्यू से डिफ्लेक्ट होगा, ओके, क्योंकि ओवरऑल लोड आपका पुली होल्ड कर रहा है और पुली के ऊपर क्या है आपकी रोप है, तो रोप पे जो एक्सटेंशन आएगा वही एक्सटेंशन और डिफ्लेक्शन क्या आएगा लोड में आएगा, तो एट द सेम मैनर वी कैन फाइंड आउट फॉर फिगर बी, यहाँ पे भी आपका टेंसाइल फोर्स कितना है 10 किलो न्यूटन्स का है, ओके, तो फॉर फिगर बी हियर इट इज कैरिंग बाय पुली ओनली, तो फॉर द सेक्शन the 10 kilonewton is divided into two equal parts, okay, for stress in the rope क्या होगा ये जो फोर्स है वो फोर्स डिवाइड होगा टू पार्ट्स में, 10/2 इक्वल्स टू 5 किलो न्यूटन, सो स्ट्रेस कितना आएगा 5 किलो न्यूटन अपॉन एरिया, एंड एक्सटेंशन कितना आएगा फॉर द सेम इन द सेम as the same manner for figure A we can find out the stress divided by Young's modulus into total length, okay, now the deflection of load will be 7.5 divided by 2, that means 3.75, यहाँ पे मैंने हर एक वैल्यू की हाफ क्यों की है, क्योंकि यहाँ पे जो डायग्राम है, वो डायग्राम शो कर रही है कि ये लोड जो है, ये लोड पुली के इंटर्न रोप ले रहा है, डायरेक्टली रोप नहीं ले रहा है। ओके, पहले ये पुली पे सपोर्टेड है और पुली के इंटर्न ये जो है वो लोड रोप ले रहा है। इसलिए मैंने क्या किया, ये जो 10 किलो न्यूटन है, वो 10 किलो न्यूटन इक्वली 2 पार्ट्स में डिवाइड किए, और जो भी एक्सटेंशन आया है आपकी रोप में, वो एक्सटेंशन भी मैंने क्या किया है, 2 पार्ट्स में डिवाइड किया है। और लोड का डिफ्लेक्शन कितना होगा, जो आपकी लेंथ में एक्सटेंशन आएगा, रोप की लेंथ में एक्सटेंशन आएगा, उसके हाफ ही क्या होगा, लोड आपका डिफ्लेक्ट होगा। ओके, क्योंकि वहां पे पुली भी है, पुली के ऊपर आपका क्या है, लोड अप्लाई किया हुआ है, और पुली के ऊपर आपका रोप भी है। तो जो भी लोड आएगा वो लोड हाफ इक्वली 2 पार्ट्स में डिवाइड होगा, और एक्सटेंशन भी जो आएगा वो इक्वली 2 पार्ट्स में डिवाइड होगा। ओके, नाउ second is steel tie rod 40 mm in diameter and 2 meters long is subjected to a pull of 80 kilonewton. Here a pull of 80 kilonewton is there. To what length the bar should be bored centrally so that the total extension will increase by 20% under the same pull. The bore being 20 mm diameter, take E equals to 2 into 10 raised to 5 newtons per mm square. Okay, now here they have given the rod of 40 mm diameter. So for the area we can take D equals to 40 and the area will be pi by 4 D square, that is 400 pi mm square. Okay, now they have told us that the pull force of 80 kilonewton is acting. Here we can see that 80 kilonewton pull force is acting at the both ends of this rod, and we have to bore centrally a bar we have to bore. Okay, यहाँ पे क्या दिया है उन्होंने, एक रॉड है, टाई रॉड है, 40 mm डायमीटर है उसका, 2 मीटर्स लेंथ है, एंड फोर्स ऑफ 80 किलो न्यूटन इज एक्टिंग एट दी बोथ एंड्स। ओके, हमें क्या करना है कि इस बार के सेंटर में एक बार क्या करना है, बोर करना है। ओके, एक बार हम लोग को बोर करना है, और दैट बोरिंग शुड बी ऑफ डायमीटर 20 mm। ओके, नाउ इसकी वजह से क्या होना चाहिए कि टोटल एक्सटेंशन जो है वो 20% ही इंक्रीज होना चाहिए। ओके, उन्होंने कंडीशन क्या दी है कि एक्सटेंशन, टोटल एक्सटेंशन विल इंक्रीज बाय 20% अंडर द सेम लोड। सो सिग्मा कैन बी कैलकुलेटेड एज योर लोड डिवाइडेड बाय योर एरिया, 80 into 1000 divided by 400, pi will be your stress. Okay, by simple mathematical calculation we get 200 divided by pi newtons per mm square. Now for this, strain will be, or extension will be delta L equals to sigma upon E into L, सिग्मा अपॉन ई इंटू एल। तो सिग्मा की वैल्यू हम लोग ने निकाली हुई है, ई उन्होंने दिया हुआ है 2 into 10⁵ and total length is 2 meters, that is 2000 mm. Okay, so the delta L will be 2 divided by pi mm. Okay, ये हुआ इस रॉड के लिए। Now we will move further for the extension of bore. Now if the extension of bore is made, now that extension after the bore equals to 1.2 into 2 by पाई। ओके, दिस एक्सटेंशन, ये एक्सटेंशन मैंने कैसे निकाला, क्योंकि 20% ही उन्होंने क्या बोला है, 20% ही आपकी क्या होनी चाहिए, लेंथ इंक्रीज होनी चाहिए। ओके, तो आपका टोटल आपका इंक्रीज इन लेंथ कितनी है, 2 बाय पाई है, जो हम लोग ने अभी निकाली है, 2 बाय पाई। ओके, डेल्टा एल इज 2 बाय पाई। अब नाउ क्या होना चाहिए कि उसके ही 20% इंक्रीज होना चाहिए। तो 1.2 मैंने क्यों लिया है, क्योंकि 1 प्लस 0.2 that equals to 1.2 into 2 by pi। तो टोटल एक्सटेंशन कितना हुआ आपका आफ्टर द बोर, 2.4 divided by pi mm। ओके, Now let the bar be bored to the length of L meters. Area at the reduced section. यहाँ पे हम लोग ने जो बार डायग्राम में मैंने जो शो किया है, आप देख सकते हैं यहाँ पे डायग्राम में बोर की लेंथ कितनी अज्यूम की है, L अज्यूम की है. ओके, एंड द डायमीटर शुड बी 20 mm. they have given the diameter should be 20 mm. so एरिया कितना होगा, अभी एरिया जो बोर है उसका एरिया रिड्यूस्ड होगा. रिड्यूस्ड सेक्शन का एरिया कितना होगा, अभी ओवरऑल एरिया, टोटल एरिया ऑफ बार इज 400 पाई माइनस रिड्यूस्ड सेक्शन का एरिया कितना होगा, माइनस दैट एरिया ऑफ बोर. सो पाई बाय 4 डी स्क्वायर विल गेट 300 पाई एज द एरिया ऑफ रिड्यूस्ड सेक्शन. ओके, जो बोर है वो मैंने उसमें से माइनस किया तो रिमेनिंग एरिया जो रिड्यूस्ड सेक्शन का है वो कितना आया, 300 पाई आया. नाउ द एक्सटेंशन ऑफ रॉड इज, what will be the extension of rod? Here simple calculation है, simply we have to take the value of delta L sigma upon E into L, sigma upon E into L. Okay, so here sigma upon E for first 200 divided by pi into E, 2 minus L into 1000 plus 80,000 divided by 300 pi into E into L into 1000. Okay, so by simply taking the mathematical calculations we can get 2.4 divided by pi. Okay, 2.4 divided by pi will be the extension of that rod. Okay, now we can here written as 2 minus L plus 4 by 3 L equals to 2.4. Okay, this is the simple mathematical calculations. We have simply shifted this in right hand side. We'll get the simply equate this denominator and we'll get 6 minus 3L plus 4L equals to 7.2 and L equals to 1.2. Okay, L equals to 1.2. Here the length will be, the bar of length of bar will be 1.2, so that when we board centrally a bar, the what length of that bar should be, the length of that bar should be 1.2. Okay, the central length of that bore bar is should be 1.2. Now the second example, a rigid bar ACDB is hinged at A and supported in a horizontal position by two identical steels. Here steel wires are there which are supported to this ABCD bar. Okay, a vertical load of 30 kilonewton is applied at B. This 30 kilonewton load is applied at B. Find the tensile forces T1 and T2 induced in these wires by the vertical load. Now this is the ABCD is your rod and this is nothing but your deflections. Okay, figure A shows the steady position and figure B shows the position when 30 kilonewton load is actually applying at that end. Okay, when what happened, this end is not supported or this end is not fixed. So when 30 kilonewton is acting, what happened, this A will shift towards upper direction. Okay, and this wire will have some extension and this wire will also have some extension. This dotted position or dotted portion shows the extensions in wire, and from C the bar will shift to C dash, and from D the bar will shift to D dash. From B this bar will shift to B dash when the 30 kilonewton force is actually acting. Okay, now they have said that these two wires are identical ones. So the area of two wires should be same, elastic modulus should be same, and length also should be same. Okay, and also they have given that the load of 30 kilonewton is acting. So 30 kilonewton load equals to 30 into 10 raised to 3 newtons, as I have already explained what both figures are explaining. Now let the T1 is tension in first wire and T2 is the tension in second wire. Delta 1 is the extension of first wire and delta 2 is extension of second wire. Though to what length that wire is extended and to what length the second wire is extended. Now since for first the rigid bar, since the rigid bar remains straight, the extension delta 1 and delta 2 will be given by simple, the geometric calculations are there. Delta 1 divided by delta 2 equals to AC divided by AD equals to 1 divided by 2. Okay, this is the formula for similar triangles. Okay, similar triangles, we can consider these triangles. Delta 1 divided by delta 2 equals to AC divided by A to D. Now the AC value is 1 and AD value is 1 plus 1 2. They have given the lengths. So 2 delta 1 equals to delta 2 value will get. Okay, 2 delta 1 equals to delta 2, but the delta 1 is the extension in wire 1, that means your extension in wire EC. Therefore extension or deflection delta 1 equals to stress in EC into length upon E1. Okay, now the stress in EC can be calculated as the tension force in first wire divided by area of first wire into L1 upon E1. This simply we can arrange and we get T1 L1 upon A1 E1. Okay, for similarly for second wire we'll get delta 2 equals to T2 L2 upon A2 E2. Okay, simply we can do here for extension for delta 1 and delta 2. Okay, this is very simple. Now secondly, substitute this in 2 delta 1. This is the value of delta 1 and this is the value of delta 2. Okay, so simply 2 delta 1 equals to delta 2 we can do here, and as we have already know that A1 A2 equals to E1 E2 and equals to L1 L2. ओके, उसकी एरिया, इलास्टिक मॉडुलस एंड लेंथ भी सेम है. सो यहाँ पे A1 कैंसिल हो जाएगा, E1 कैंसिल हो जाएगा एंड L1 ऑल्सो गेट कैंसिल. सो रिमेनिंग इज 2T1 equals to T2. Now we have to take the moments of these forces about the bar A. Okay, about the bar A. We'll get again to the diagram here. Now we'll take the moments. Now first is यहाँ पे T1 है और यहाँ पे T2 है. ओके, एंड यहाँ पे क्या है आपका फोर्स 30 किलो न्यूटन से. नाउ T1 will act and T2 will act in same direction, while that of the 30 kilonewtons will act in opposite direction. Okay, so T1 into perpendicular distance is 1, here 1 is given. T2 into perpendicular distance 1 plus 1, that is 2, and 30 kilonewtons into perpendicular distance is 1 plus 1 plus 1, that is 3. Okay, so T1 into 1, T2 into 2 and 30 into 3, that is your perpendicular distances. So T1 plus 2T2 equals to 90 will get you the equations of all the moments. Now substitute the values of T1 and T2 and we'll get T1 equals to T2 equals to 2 T1. So we'll substitute this here. We'll get, by simple mathematical calculations, we'll get T1 equals to 18 kilonewtons. Okay, and substitute this value T1 in that equation. T2 equals to 2 T1. We'll get 18 by 18 into 2, that is 36 kilonewtons equals to T2. The tension in first wire is 18 kilonewton and tension in second wire is 36 kilonewtons. Okay, now we'll move further for the next example. This is a rectangular base plate. This is the rectangular base plate which is fixed at each of its four corners by a 20 diameter bolt. Okay, and the nuts as shown in figure. The plate rests on the washers of 22 internal diameter and 50 external diameter. Upper washer which are placed between nut and plate are of 22 internal diameter and 44 external diameter. Okay, upper का कितना है 22 internal and 44 external, and lower का कितना है 22 internal and 50 external. Now, if the base plate carries a load of 120 kilonewtons, including its own weight, now its own weight is equally divided into four corners, they have said. Now, we have to calculate the stress on the lower washer before the nuts are tightened. Now, what would be the stresses in upper and lower washer when the nuts are tightened so that it produced the tension of 5 kilonewtons in each bolt? Okay, now the base plate here they have said that the base plate is carrying load of 120 kilonewtons. Okay, we are in that case we have to calculate the stress, and again what would be the stress in upper and lower washer we have to calculate when the nuts are tightened. Okay, and when they tight they produce the tension force of 5 kilonewtons each. Okay, now from this information, this is your top washer, this is your lower washer, and this is your base plate, and this is your nut. Okay, now we can find out the area of lower washer. The area of lower washer we can find out by using pi by 4 d square. Okay, but for lower washer they have given for lower washer the dimensions here. Internal is 22 and external is 50. So d will be 50 square minus 22 square. Area of lower washer will be pi by 4 50 square minus 22 square, and the load transmitted to lower washer will be, अभी उन्होंने क्या बोला है कि 120 किलोन्यूटन का जो बेस प्लेट पे लोड है वो लोड इक्वली डिवाइड हो रहा है. ओके, अभी उसके कॉर्नर्स पे कितने हैं 4 कॉर्नर्स है, तो 120 मैं क्या करूँगी इक्वली 4 पार्ट्स में डिवाइड करूँगी, तो 120 डिवाइडेड बाय 4 विल बी द लोड ट्रांसमिटेड टू लोअर वॉशर, that is 30 kilonewton. Now the stress will be this force divided by this area. 30 kilonewtons divided by your area will get the stress intensity at lower washer. Okay, the first question is over. Then when the nuts are tightened, अभी क्या होगा, उन्होंने क्या बोला था फर्स्ट पे नट्स टाइट किए नहीं है, अभी नट्स उन्होंने क्या किए हैं टाइट किए हैं, और वो टाइट करने के वजह से 5 किलो न्यूटन का जो टेंसाइल फोर्स है बोल्ट की वजह से वो ऐड हो रहा है. ओके, अभी यहाँ पे टेंशन फोर्स कितना हुआ 5 किलो न्यूटन का टेंशन फोर्स हुआ. तो अपर वॉशर का एरिया कितना है, अभी लोअर वॉशर का 50 माइनस 22 था, यहाँ पे लोअर अपर वॉशर के लिए उन्होंने दिया है कि 22 inner and 44 external. So 44 square minus 22 square, area will be pi by 4 d square. We'll get 1140.38 mm square as the area of upper washer. Okay. Now the stress intensity for this is, we have the tensile force of 5 kilonewtons as induced by that tightening of bolts. So 5 into 1000 divided by area will get the stress intensity in the upper washer. Okay. So now what happened, the compressive load on lower washer we have to calculate. The total compressive load on lower washer will be, first 30 kilonewton load, first 30 kilonewton load plus this 5 kilonewton load which will act due to the tightening of bolts. Okay, so 30 plus 5, total compressive load will be 35 kilonewton. So they ask us to calculate the stress intensity in lower washer when bolts are tightened. So stress intensity in lower washer when bolts are tightened is the total compressive load of 35 kilonewton divided by area of lower washer. This is the area of lower washer. So stress is load upon area is equal to 22.10 newtons per mm square. Okay, this will be your stress intensity in lower washer ड्यू टू द टाइटनिंग ऑफ बोल्ट. यहाँ पे आपको समझ में आया होगा, जब हम लोग ने बोल्ट टाइट किए नहीं थे तब लोड कितना लिया था, जितना लोड उस पे एक्ट हो रहा है 30 किलो न्यूटन्स का उतना ही लिया था. लेकिन यहाँ पे अभी क्या हो रहा है कि जब बोल्ट टाइट किए हैं तो वो जो बोल्ट टाइटनिंग की वजह से कंप्रेसिव लोड आ रहा है, क्योंकि बोल्ट हम लोग टाइट कर रहे हैं तो यहाँ पे क्या होगा, पुश फोर्स एक्ट होगा. ओके, पुश फोर्स एक्ट होगा फ्रॉम दी बोथ एंड. तो कंप्रेसिव लोड ऑफ 5 किलो न्यूटन इज, वी हैव टू ऐड दैट 5 किलो न्यूटन. सो 30 प्लस 5 या 35 किलो न्यूटन का लोड जो है वो लोअर वॉशर पे एक्ट होगा. तो स्ट्रेस इंटेंसिटी लोअर वॉशर की कितनी होगी आफ्टर टाइटनिंग ऑफ बोल्ट, 35 किलो न्यूटन का लोड डिवाइडेड बाय एरिया ऑफ दैट लोअर वॉशर. ओके, फ्रॉम दिस the bars of different numericals on bars of different section is over. Now for further we'll continue with the extensions of tapering rod and extensions of compound sections. Okay, thank you.